My name is Cam. We'll be going over Lab 1, comparing constant velocity. The contents of the lab that we'll be going over within this report. The principles we applied for this lab are the inertia, Newton's first law. An object in motion will continue in motion in the same direction and speed unless acted upon by another force. And the second one we use is F equals ma, Newton's second law. If the net force acting on an object is zero while it's in motion, then it will have no acceleration. It will remain in that same constant velocity, which is similar to the first law when we use it in this application and definition. The purpose of this experiment was to compare data from a computational model to observational data from experimentation that shows a connection of how constant velocity can be viewed conceptually in physics. Equations we used in the context of constant velocity for this lab are Newton's second law to show relation of F net to acceleration. We then use velocity update, which we know is just Vf equals Vi in this context, since F net must be zero. Then we use the average is equal to Vf, which we can only use whenever we know constant velocity is being applied to the object. And then we use position update so we can find the position and compare the results. For the experiment, we used an eraser for the object that was being recorded. For factors to consider, we needed to consider friction, wind resistance, and anything else like maybe air resistance that could be applied to the object during its recording that may have affected its velocity. Predicted data, we use GlowScript to track the expected movement of the object if it were to actually move at a constant velocity. For observational data, we use Tracker to get the points of distance within the frames of the video. And how we found the results, I used the dot point graph on Google Sheets to compare the observed data to the predicted data to see if the eraser was actually moving at constant velocity over the period of time. The procedure, we attempted to record an object moving at a constant velocity. Then we wanted to move the video to the tracker to get the observed values. After that, we wanted to code values to GlowScript to get the predicted values. Then finally, we wanted to compare the results using Google Sheets and plotting the graph. System of this experiment, we have the eraser, and the surroundings would be the table, the ruler, and effectively everything else. Some of our initial boundaries were the initial position, where it started at 0.102 meters. This y coordinate doesn't actually matter for the sake of this experiment. We know that no net force should be applied if we choose to ignore friction for the sake of this lab. Then after that, to get initial velocity, we used the first two points where we did x2 minus x1 divided by delta t. These are what the initial boundaries would look like in GlowScript after we were to code it in to get our predicted values. You can see that our mass is 1, though it doesn't matter for the sake of this lab. You can see that t started at 0, and delta t moves within the frame rate of the video being 30, so also 0.033. You can then go and see that our F net is 0 all around because we want net force to be 0 for constant velocity. You can see our position update formula over here as well. These are the data points that we got from using Tracker plotted on a position over time graph. This graph compares the predicted position to our observed position. The predicted position would be the eraser who was actually moving at constant velocity, while the observed position is what we actually see in the video. You can tell that through the plots on the graph here, the distance between them, that our eraser was not actually moving at constant velocity as we would have hoped through the recording of the video. Possible reasons for this error could be friction, especially due to the rough surface of the eraser to the table, any tracking mistakes, not properly tracking the middle of the object perfectly, any calculation errors that I could have made, especially when finding the initial velocity, and any other human error oversight. If the axis flipped, then the slope would become a negative slope graph, and the signs would switch and become opposite. And we cannot detect any specific push and pull forces with the information given. We just know that the net force of the object should be 0, and that we are looking for the constant velocity of the object. Due to the curve of the graph within the observations compared to the predicted slope, we can assume that the eraser did not properly portray constant velocity with 0 net force during its movement in the video. Thank you for watching.